Good morning, everyone. A confirmation about the audio, please. If the audio is working fine, thank you. Today I saw radiation fog because of morning class. Okay. At least because of this, you are able to observe something. So I'll take it as a positive thing. So hello, a very warm good morning to all of you, and welcome to Byju's exam prep. Welcome to another session of climatology. Now, we are basically nearing the end of the portion of climatology with certain important portions also left. But as far as the concept laying is done, this is where the concepts that we have studied will be applicable for us to understand the Indian climate also, as well as in order to help us understand the world climate and the climatic distribution. So, yesterday, we have had a comprehensive study about the portion of fronts, frontogenesis, the different types of fronts, the kind of weather associated with each of these fronts. Then we observed the formation of a mid latitude cyclone or a temperate cyclone. We observed where this temperate cyclone is created, where it is observed mostly. So it is observed in the region of the mid latitudes and it is a byproduct of frontogenesis. But we also stressed on the fact that not every front will lead to a development of a cyclone. But for the development of a cyclone, you do need the existence and formation of a front. So, thereby, we moved ahead and understood the various different stages of the temperate cyclone formation. We understood what is a bomb cyclone. Then we moved on to understand the tropical cyclone, whose region, formation, process, properties are drastically different as compared to that of a temperate cyclone. That is something that we studied. Now, today we are going to proceed ahead from here, and then we are going to move into the portions of Walker circulation, El Nino, La Nina circulations, or Enzo circulations as they are known. And we are going to try to grasp that idea about what these Enzo circulations are about and their overall impact. Then we will move on to the portion of Indian Ocean dipole and Madden-Julian oscillation. But till now, if I ask you, do you have the basic idea that where you have the low pressure, what is the conditions experienced, or why is it that a region experiences a thermal low pressure? Why is it that a region experiences high pressure? And if there's a high pressure, what is the weather associated, the climatic conditions associated? If that much portion is clear, that basic idea about the creation of low pressure, formation of a high pressure, that basic idea would be more than sufficient to help you navigate through the remainder of the portions. So, here, before we proceed ahead with the discussion, we are going to talk about, first of all, the effect of the air masses on climate. How is it that air masses influence the climate? Now, basically, if you think about it, you should have enough idea from this about this particular topic that you should be able to write easily 300 words if required. But what is it that you will write on the effect of air masses on climate? The first thing is the influence on temperature. We do know that air masses, they influence the temperature in an area. How? By the process where, let's suppose, the warm air mass comes into a cold air territory, or vice versa, the cold air mass comes into the region of the warm air. So by the process of advection, by the process of advection, temperature is influenced, where we know warm air mass increases the temperature, and cold air mass causes a dip in temperature. Okay, that is the factor or the influence on temperature. Now here you can always give various examples. For example, the cold polar air mass, let's suppose it comes to the lower latitudes, it causes sub-freezing conditions or sub-zero conditions, very harsh winter in the region of North America, in the region of Northern Europe, in the region of Siberia, Northern Asia. Sometimes it also happens that warmer air mass prevails for a very long period of time over this region of Europe or North America or North Asia, creating a different kind of heat waves altogether. So the influence on temperature is major. In the case of the frontal formation also, the temperature is influenced. Then you have the influence on precipitation, the amount of rainfall caused. So when we talk about precipitation here, maritime air mass, maritime air mass causes rainfall over land, other regions, coastal areas, right? Where the maritime air mass has got a significant amount of influence associated. Then the fronts and cyclones. We do know that these air masses, they form various different types of fronts. And if it is a warm front or a cold front, the climatic conditions in each of them is going to vary. So air masses can form various different types of fronts, lead to air masses, lead to formation of fronts. Okay, and there it is warm front or cold front or even an occluded front. Now, each of them will have their own type of influence on climate. We have seen that in the case of a warm front, you will have a long, continuous, moderate amount of rainfall, which is going to be experienced over an area. In the case of a cold front, we do know that you have the formation of cumulonimbus, dense cumulonimbus clouds, and you will experience violent spate of rainfall combined with thunder and lightning. And in the case of an occluded front, because the fronts are closing in, you can many of the times have the simultaneous occurrence of warm and cold fronts. So you can have a stormy weather condition around the region of low pressure, and thereby you can have heavier rainfall on this one side and moderate rainfall on the other, associated with strong wind movement. So these are the various different weather phenomena that we have already observed. And these air masses also lead to the formation of cyclones. Now, cyclones, when we talk about temperate cyclones, temperate, then convergence of warm and cold air mass. And when we talk about tropical, caused due to warm and moist air mass. Okay, the tropical conditions are, or the tropical cyclones are created due to warm and moist air mass, and we do know the impact of it. We do know the impact of the case of a temperate cyclone as well. So these are the various different phenomena. So here, if let's suppose a question is asked, I expect you, or rather UPSC expects you, to elaborate upon each of these points in one or two sentences. That's it. That will be enough to carve out 250 to 70 words, right? About what and how the property of air masses influence the climatic conditions of a region. So, that is the crux of this particular chapter. Now, here let us take a look at few of the questions, mains PYQ. The first question in itself: discuss the concept of air mass and explain its. Now, discuss the concept of air mass and explain its role in macroclimatic changes. Now, when we talk about this particular question, the first one, the concept of an air mass. What is the concept of an air mass? A large sample of air having homogeneous property of temperature, pressure, and humidity spread over an area, having the homogeneous property gained from the surface or a source region, is an air mass, is known as an air mass. Now, the air mass is classified based upon the classification of the source regions. Accordingly, you have maritime, continental air masses, tropical, equatorial, polar, Arctic, and Antarctic air masses, forming a variety of various different combinations. These air masses have a significant influence on climatic conditions of a region. And accordingly, after that, you can do that classification: influence on temperature, influence on rainfall, and also due to fronts and the occurrence of cyclones, what is the influence that is created. So thereby you should be able to carve out the answer which is required. I hope there won't be any issue caused in this question. Only coastal precipitation is concerned as the effect on climate. Only not all inland rainfalls considered as climate. All inland rainfall, see, when you consider a convectional rainfall, convectional rainfall can never be attributed to the property of the air mass. Convectional rainfall is a localized phenomena. Okay. So convectional rainfall, wherever it occurs, it is not because of the property of a large air mass. Secondly, when you talk about the moist air masses causing rainfall, for example, in India during the monsoon season, it is the moist maritime air mass which brings rainfall across the entirety of the country. Right. It is the work of the moist air mass coming from the coastal areas which brings rainfall all across India. So it is, but because maritime air masses will have their maximum influence on the coastal area in the regions of the coastline. For example, western portion of Europe. For example, the region of Britain or UK. Now, think about it. If you look at the position And for a brief moment, listen to this carefully. If you take a look at the position and the location of the region of Western Europe, such as, let's suppose, Belgium, France, Netherlands, UK, I hope you are aware about the rough location of these areas. Now, will these areas be expecting an offshore wind, or will these areas experience an onshore wind? What do you think? When we talk about Western Europe and UK, will these areas experience offshore winds or onshore winds? If offshore, which wind are you talking about? If onshore, which wind are you talking about? Good. Ankush, Vibhu, correct. Anjan, correct. Krishika, trade winds do not never will be observed in that mid latitude. Trade winds always in the tropics, from Tropic of Cancer almost to around equator, and Tropic of Capricorn to equator. So here in the Western Europe and UK, you will experience onshore winds in the form of westerlies. Now these westerlies, when they move over, can we say that these westerlies, when they hit the region of Western Europe and UK, they represent a moist air mass, maritime moist air mass? Now, what will be the impact of that in these areas? They will cause heavy amount of rainfall on a daily basis. That is in the region of UK, Western Europe. You will have these onshore winds continuously coming from the region of the Atlantic. The air will be very moist. That moist air will hit the land, cause rainfall. That is the reason why the region of UK ends up receiving rainfall almost on a daily basis throughout the year, almost on a daily basis. So, this type of climate, which is found where you have moderate temperatures, not very cold winters, not very hot summers, but you have the continuous occurrence of rainfall throughout the year. We will study later. That is also what is known as the British type of climate. Now, this British type of climate is induced because of what? Because of the maritime air mass. Its influence is found to be present where? In the coastal areas. Now, the same westerlies, they will blow even over the region of Central Europe as well as in the region of Eastern Asia, eastern part of Asia, Eastern Europe, and the region of Siberia. But will these westerlies be able to bring any rainfall by the time that you are talking about the Central and Eastern Europe and the inland portions of Russia? No, because by the time that these westerlies would reach there, already they would have been very, very dry. All the moisture would have been drained out at some place or the other, and they won't cause that rainfall. So, in the internal portions of the continents at the same latitude, the latitude where Britain is situated, at the same latitude, if you move to the internal portion of Europe and Russia, you will experience lesser amount of rainfall. Now, again, apply your logic. Lesser amount of rainfall or dry conditions in the interior of the Eurasian continent means, where is it that the temperature will be more moderate? In the Western Europe and UK, or in the internal portion of Eurasia? Think about it again carefully. Listen to this carefully. We have seen about the variation in rainfall because of the winds. Now, the same westerlies, they blow over to the UK and Western Europe also, and they move over from the portion of Central Europe, Eastern Europe, and Asia also, the Eurasian region. Now, The amount of rainfall will be obviously more in the coastal areas in the western coast of the Eurasian continent, where you will have almost daily occurrence of rainfall. But what about the central and the eastern portion? That will be drier. So, where is it that the temperature or the climate conditions will be moderate throughout the year? In the portion of the central portion and interior portion of Eurasia, or in the coastal, western coastal areas of Europe? Where is it that climatic conditions will be more moderate? Very good. Beautiful. Always, the coastal areas will experience a moderation of climatic conditions. Why? Because in these coastal areas, you have the daily occurrence of rainfall, which will moderate the climatic type. So that is why interior portions of Europe, the region of Siberia, they experience extremities of climate. The winters get very cold, right? And whereas in the same latitude, when you talk about the region of Western Europe, you don't experience that very cold winters. So it is the feature of the moist air mass which will influence the climatic condition in different areas as well. Okay. So here, if you want to give examples, you can basically conjure up examples from various different parts of the world. Now, the next question that is there: tropical cyclones are largely confined to South China Sea, Bay of Bengal, and Gulf of Mexico. Why? Now, this is one of those questions which I would ask you to hold it up for a brief moment, because you can basically answer it in a very shallow manner, because these are smaller water bodies getting heated up, etc. But I want you to give a comprehensive answer where you are able to link the portion of climatology along with oceanography. Most of the answers in UPSC, everybody would have rectified some book, everybody would have replicated whatever is there in the book. Those answers, even in the optional, those answers will always stand out, where you are able to find an interconnectivity between different units, different topics, and even, if possible, different subjects. So here we are going to try to find an interlink about the property of Gulf of Mexico, South China Sea, Bay of Bengal, and we are going to talk about the fact that how the oceanic properties also, along with the wind patterns, they influence the occurrence of tropical cyclones in this area. So hold on to this particular question. By the end of maybe Tuesday's lecture, you should be able to answer this beautifully. The recent cyclone in the east coast of India was called Phylin. This is an older question. How are the tropical cyclones named across the world? We have discussed this. So basically, how is it that they are named? You have the initially the Tropical Cyclone Warning Center, the TCWC, Tropical Cyclone Warning Center, which raises an alarm whenever you have a significant low pressure created over the water bodies. This alerts the RSMCs which are present across the world. You have in total around 6 RSMCs. For the Northern Indian Ocean, you have the RSMC New Delhi, which is in fact situated in the Indian Meteorological Department's office in New Delhi. So there, these RSMCs then take up a list of names. Now, who gives that list of names? So the various countries of the region who sit together under the aegis of WMO and UNSCAP. UNSCAP. These basically give you an idea, or these countries, they sit together and thereby they submit a list of names. As far as the Northern Indian Ocean is concerned, you have 13 countries now, from Bangladesh, India, and so on. These countries are arranged alphabetically, and the names given by them are placed in the rows in front. So, along with the, accordingly, you have a matrix of 169 names. One by one, the name is picked up from the list and it is given to the cyclone. Sometimes it might happen that a cyclone is very deadly, very, very deadly, claiming a lot of casualties. In that case, immediately you will observe that the cyclone or that name is struck off the list and then never to be used ever again. Even when the new list is prepared, it is kept in mind that that particular name is never used again. So, this basic fact you can always cite and you can have the answer. Then, bring out the causes for the formation of heat islands in the urban habitat of the world. We have talked about this also, from pollution to greater density of population to the aspect of the albedo. Concretization means a greater amount of absorption of these solar rays. So, all of these factors you have to bring to the table. If this question is of 250 words or 15 marks, you can bring forward the solutions also. You have to draw diagrams in all the questions. Always keep that in mind. You have to bring out at least one diagram for all the questions. Now, then, what do you understand by the phenomena of temperature inversion in meteorology? How does it affect the weather and habitants of its place? So, phenomena of temperature inversion, we do know that under normal conditions in the near the ground surface we experience a positive lapse rate, but due to certain climatic conditions, whenever you have a negative lapse rate or wherever we observe that near the ground surface colder air is present and then higher up there is a warmer air, that is that is representative of a negative lapse rate or a condition of temperature inversion. Depending upon why that inversion has happened or how that inversion has happened, you have the classification into various types: surface inversion, subsidence inversion, frontal inversion, and valley inversion. If it is a 250 worded answer, you have the scope to draw the diagrams for each one of them and write a couple of sentences about it. Ideally, how you should go about it, let's suppose you are talking about, let's suppose here, the surface inversion. So draw a kind of a box here. In that, draw the land surface. Okay. Write the terrestrial radiation, loss of heat from the land, causes immense cooling, causes immense cooling of air attached at a higher elevation, air is not cooled down at the same rate. Okay, the air is not cooled down at the same rate in the higher elevation. So this descriptive diagram, which will not occupy much space, it will not take much of your time, that will be very representative. After that, maybe in one sentence you can write: surface inversion is created during long winter nights when the surface loses heat continuously, and that leads to the ground air becoming much colder than the air above, creating a negative lapse rate. That's it. Okay, like that, you have to represent the diagram. Should we draw diagrams for 150 markers also? Yes. For any question of geography, you have to draw the diagram. That is what makes your answer representative. Otherwise, the answers of geography and polity should never look the same. In fact, you will see many of the toppers' copies. There, you will observe that basically they have cross utilized their answering ability in geography and put it in subjects such as polity and history also, where in the region or in the subject of polity and history also they are bringing out bubble diagrams, flow charts, etc. So whenever you do that, that will be, and if you are writing content in that, that will always be more rewarding, because for a brief moment understand the mind of the evaluator also. The evaluator for multiple days continuously is going to scan through the copies having the same answer, similar answer, in a written format, in a complete written format. They don't have the incentive to go through the entirety of your answer. Right. So that is why it is always advisable to underline some of the key phrases, some maybe a couple of words there, which you want the evaluator to notice, or to bring out diagrams, flow charts, so that it becomes appealing to the eye and you are able to attract the attention of the evaluator. So that is basically why it is required. Okay. Use that in all your answer writing. Do use this particular methodology. Initial days of practice, it will take some time. It doesn't happen naturally, it will take some time. That is why I always advise the laborious or the hardworking students that have a target, that before the mains examination you are able to write at least 500 to 800 answers on your own. That practice should be there, along with that presentation, that eventually the time limit etc is also adhered to. But what I find in majority of the candidates, after they have written 5 answers or 10 answers, they immediately get disheartened. The marks are not increasing. Out of 15 I have got only 5. I should have gotten 15 out of 15. I have written it with so much amount of heart. 5 or 10 answers is never going to be sufficient, right? At least 500 to 800 answers. When you practice, when you write it down, that is when all these things become ingrained in your answer writing. So how does it affect the weather? It doesn't allow the vertical mixing. In the case of frontal inversion, it can lead to the formation of, or the cloud formation and rainfall also. In many of the cases, like surface inversion, it can lead to the fog formation, radiation fog formation. Valley inversion can lead to the formation of valley fog also. If you have the case of a valley fog, immediately the temperature dips quite drastically, due to which the plants in that region, they can also die because of sudden frost, right? These are the factors that you can represent. Because of lack of vertical mixing, you have the case of the pollutant staying in the same place for a longer period of time, thereby impact. You can give the example of Delhi also in that. In the case of subsidence inversion, you can give the example of the London smog, that how in the region of London multiple lives were claimed because of that subsidence inversion. And because of that subsidence inversion, you had the situation where the entire region of London was covered in smog for so many days, claiming hundreds of lives unofficially. So that is the case where you can bring out the influence on weather and habitants. Okay. Now, after this, we come forward to the portion of atmospheric phenomena. Now, this is the portion which, to be very honest, the books, many of the books don't do enough justice. The books which do justice to it, there they have covered the portion of El Nino, La Nina in such a kind of a detailed scientific approach that many of the times it becomes bouncer over your head, right? You have very of the few books out there, and that too for specific, only for climatology or geography, which will talk about it. Factors such as Indian Ocean dipole, factors such as Madden-Julian oscillation, it is still something that bureaus of meteorology, in Australia, in France, in UK, in US, only they will be able to give you some details about it, right? So here we are going to study the entirety of the portion from Walker circulation. What is Walker circulation? Then we are going to study the portion of El Nino, La Nina, Enzo cycles. Then we are going to study Indian Ocean dipole. No, that is what Shreyas I'm trying to convey. Please don't start scouring for various different books. For this portion and the portion of Indian monsoon, I would rather suggest to you that stick to the portion of the PPT and the portion of additional reading materials. That is more than sufficient. And trust me, that will give you an advantage over many of your competition as well. And that I can say with surety, only provided you are able to recall what we have studied. Jet streams. These are the things that we are going to delve into the details of. And if you are ready enough and if you are open enough, we can explore to the depths of this also, why something happens, where it happens, and the implications of it. For example, jet streams. Everywhere you will study that jet streams are high altitude winds. But why they are formed? Why is it that the direction is always from west to east? That is something that we can delve deeper upon. Here, if possible, again, if we have a basic level of understanding, only then will I go into the depth. Otherwise, the basic understanding would do for your GS. We can even explore the areas about heat dome. That why is it that the region of Siberia, the region of Canada, they are experiencing very high temperatures during the past few summers, due to which there is substantial amount of loss of wild fauna or wild animals, because the temperature oftentimes in these northern portions of Canada and Siberia, they cross 40, 41 degrees Celsius, 45 degrees Celsius. For us Indians, it is normal summer that, okay, this time again temperature has crossed 45. But in the region of Canada and Siberia, where the summer temperature is 25 degrees Celsius, having a 45-degree temperature can be devastating. So that is something that we are going to explore here. Why you wrote N cap in El Nino? Okay. It is a very basic thing. Many of the people don't pay attention to that. In the PPT also, in many of the places, you will find that interspersely used. If I would write here Nino, this will be pronounced as, right? If you use that, it is the pronunciation. So it is not El Nino, it is El Nino, right? It is El Nino and La Nina. So that is why that N has got that kind of a capping. But I have seen many of the candidates who come to me and say that, tell me about Nino phenomena, whatever that is. And then they will say La Nino, El Nina, but it is up to you. So it is, ideally it is El Nino and La Nina. Now here, for the prelims, by the way, I had given map pointing day before yesterday. How many of us have managed to look through the maps? about the river movement and also the Pacific and Indian Ocean? Very good. Beautiful. The expected candidates. Isha, if some of them are you are unable to locate, take the help of Google and then go back to the atlas. Again, take a look at that. Okay. So don't let any portions that you have not been able to find, don't let that stop you. Look at it again. Okay. Now here, no, I deliberately did not give Yangtze because too much of map over flooding of that river information would be difficult. So here, Jayashree, I'm unable to locate it. Take a look at the physical map and thereby take a look at which areas. For example, physical map, I have given you the continents in which these rivers are found. So in those continents, try to find those names and just take a look at where, for example, I've told you Rio Grande is forming a border between US and Mexico. So you do know where to look. So like that, once you are able to locate some of the things, you will develop a knack. Any portion that you are unable to normally locate on the map, take the help of Google and then switch back to the atlas. Now many of the candidates, they have a significant and genuine fear when it comes to map pointing, because UPSC tends to ask one question or other in the prelims examination, and they run helter skelter in order to have some amount of clue that tell me the list from which UPSC is asking. Let me get hold of that list. And for that, they run from pillar to post. What I would advise you is keep an eye out for the current affairs, the portions which are in news. Those portions which are in news, UPSC will ask you the detail about those areas from a mapping perspective. For example, in the past couple of months, past 2 to 3 months, or yesterday, I hope everybody would have heard the news, the very proud news where Indian Marine Commandos actually onboarded the hijacked ship and they rescued everyone. Where is this happening? Where is the region of the Horn of Africa? Where is the region of Bab al Mandeb? Okay, Bab al Mandeb connects Red Sea with what? So these details in the Horn of Africa, for example, polar region, okay, that also. But in the Horn of Africa, which are the countries involved? Which are the countries which are present? These details you should be aware of. Let's suppose you hear the news story in the same thing or in the same series of the attacks in Red Sea. You hear the news story that US has deployed its navy from Diego Garcia. Where is Diego Garcia? There's a sovereignty issue there also. So like that, if you go for the study, explorative study, it will be much more rewarding. A couple of months back, you have or the ongoing Israel Palestine issue. Now due to that, you have the free passage provided to Egypt. So where is that Sinai Peninsula which has been talked about? Where is the Negev Desert? Okay, which of the regions they share their port with Mediterranean? Okay, so these things, if you always proactively associate the portion of current affairs with the region of maps, that will always be much more helpful than rectifying from a particular list. That will enhance your idea about IR also, what is happening internationally. Okay. Now, here, yes, Rafah crossing, where that Rafah crossing is. So, it's okay, Godavari. In the initial days, it will take some time. So, here for the prelims, you have the relevance of Walker circulation. I will show you the types of questions also which have been asked. The El Nino, La Nina cycles or the Enzo cycles. jet streams, MJO, and IOD. So for prelims, the basics of everything is relevant. But when it comes to mains examination, UPSC won't go into the details of many of these areas. So for the mains examination, Enzo cycles, jet streams. These are the portions for mains examination. Nowadays, UPSC has started a new trend. And that trend is, I will show you with the type of the question also. It is no longer asking the, in a multiple statement question in the prelims. UPSC is no longer relying upon only one topic. UPSC will give you in these multiple statements one question from, let's suppose, jet streams, one question from cyclones, another question from air masses, and then you will have to choose which of them are correct or incorrect. So that is where a cross utilization of concepts and a clear concept is always rewarded and required. Okay. In cold air, being heavier particles are very close, so there should be more molecular interaction. No. Why is it that the particles are very close? The particles, Pulkit, in the colder region are, or in the colder air, are very close because you have extracted the heat energy out. So once you have extracted the heat energy out, that means what? That means they don't have that energy to be moving. That is why they come together, they slump together, right? So let's suppose five or seven individual organisms, you take all the energy out of them, they will slump together. Does not mean they will have more interaction with each other. When they are together with full energy, they will have more interaction. But when they are lying there because of lack of energy, there will not be enough molecular interaction between them. I hope you are able to get. Okay, Colorado is seen in the western and the eastern part of Rockies, but they are not interconnected. So the part to the western, or the portion to the west, that is the one which moves through the region of the Colorado Plateau. That is where you have had multiple uplifting and downlifting and degradation of the land. And that is where in certain areas the disconnect has also occurred in the river systems, but that is the major river that you have to consider. Okay. So now we start with the basics of, and starting with the revision of the portion of rise and fall of air parcel, we'll be starting first of all with the Walker cell. Now, rise and fall of air parcel. We have seen that rise and fall of air parcel can happen due to thermal conditions, due to heating and cooling, and can also occur because of the dynamic conditions. Here we are going to refer to the thermal conditions. Now, when we say thermal conditions, what do we mean by that? So basically, that there we have seen when surface is hot, surface is hot, low pressure is created, or inversely, air warms up and rises, a low pressure is created. And then we do know when the surface is cold. Air cools and sinks, and a high pressure gets created. Okay, we do know this, that you have the rise of air parcel in the warmer areas. We do know that you have a fall of air parcel in certain areas. Now, in the tricellular model, or the various different models of air circulation and the movement of air that we have studied till now, you would agree with me when I say that in all the various things of air circulation, we have studied about circulation of air between different latitudes, from maybe a lower latitude to a higher latitude to a lower latitude. Because in tricellular model of atmospheric circulation, what is it that we saw? In the tricellular model of atmospheric circulation, what did we see? We saw that around the region of equator, you have rising air. This air then sinks around 30 degrees, 30, 35 degrees, or 25 degrees. And there, again, this goes. It here in the polar region also you have sinking air because of very cold conditions or a high pressure. Now these two air masses will converge, they will rise up, and you have a complete circulation. Now, this circulation that we saw happened between different latitudes. And why did this circulation happen? Because different areas of the planet, they get heated and cooled down to a different rate. It is not as if they will all indicate or exhibit the same temperature or the same rate of heating and cooling. Different areas, they get heated and cooled down to a different rate. Right? The polar regions, they are very, very cold. The lower latitudes, they are very hot. So that is why there is this difference. Having said that, when you talk about the regions such as Pacific is a very large ocean, very, very large ocean. Now, in this region of Pacific, you have the winds, the surface winds. Now, if I ask you, the surface winds over Pacific, will they be strong enough or will these be weak winds? The answer in this case obviously is going to be the strong winds, because we are talking about a water body, an uninterrupted large extent of water body without having much of the interruptions in between. Right? So Pacific is going to be very large, is a very large water body with very strong wind movement. Now, you had an individual, a climatologist with the name of Gilbert Walker. Now, Gilbert Walker was an acclaimed climatologist of his time, and he was considered to be one of those young geniuses that you have, on whom you have a lot of hopes. For example, yeah, in almost all the fields of life, in almost all the areas of career building, you would have observed that there are few of the individuals, the the shiners, who basically you have pinned a lot of hope that they will achieve great things. So Gilbert Walker was amongst one of those who was said to be destined to achieve very great things. Now, Gilbert Walker was convinced that in the different areas of Pacific, the heating and cooling across the western portion of Pacific is not the same as you consider it to the eastern portion of Pacific. By western portion of Pacific, we mean the coastline of Australia, Indonesia, Philippines, etc. By eastern portion of Pacific, we mean the South American coastline, the region of North America and their coastline. So he found out that there is a difference of temperature between the western end of the Pacific and the eastern end of the Pacific. Now, due to that difference in temperature in both ends of the Pacific at the same latitude, not at different latitudes as was earlier indicated, at the same latitude, you have a different pressure condition. A pressure gradient force comes into existence because of difference in temperature, and there is a circulation which is attained. Now, this circulation, he observed, so that phenomena of circulation happening at the same latitude across different longitudes at the same latitude was something that Gilbert Walker discovered. Gilbert Walker was, in fact, very convinced that this circulation in the Pacific has got a significant role to play, even in terms of influencing the Indian monsoon. That is when he took the job in Indian Meteorological Department. He basically, in the first decade of the 1900s, the first decade of 20th century, Gilbert Walker eventually rose up to the rank of the head of the Indian Meteorological Department. But when he came over to head the Indian Meteorological Department, his prime purpose was to find a relation between the Walker circulation in the Pacific and the Indian monsoon. And that is something he could not find. And during his tenure at Indian Meteorological Department, you can argue that his developmental phase was actually over. He could not come up with any new discoveries, any new foundations for that matter. So that is something. Okay, is there an issue with the audio? Okay, just a moment. Is the audio working fine now, guys? Is the audio fine? Okay, okay. So before we study about this Walker circulation, what this Walker circulation is, why this happens in the Pacific, I want you to understand few of the basics about the oceans that we will cover in the next few modules. But before that, let us have some idea about the oceans. That will be much more rewarding for us in this present context. So here, basically, let's suppose you talk about any oceanic surface. Now, for these oceans, what is the prime source of heating of these oceans? The sun, the solar rays, they are the prime source of heating. So, where is it that the temperature will be highest? Almost always at the surface, especially the tropical waters. We are talking about the equatorial and tropical waters. So, here, the surface temperature will be very high. So, can we say that as you move lower down into the ocean, the temperature drops? Can we say that? Temperature drops with depth. That can be thought to be as subsurface water. Subsurface means below the surface. Waters are much colder as compared to the surface. We can think about it in this manner. Now, once we have established this fact, let me remove this solar rays. Now, let's assume that, and we have already talked about the fact that over the oceans, when the winds blow, they blow with great ferocity, they blow with great speed. So, if you have the winds blowing over this region, naturally they will be faster, they will be powerful. Now, these winds, they will have some amount of frictional drag. So, that frictional drag will allow these winds to drag the surface water along with them, to carry the surface water along with them. Let us suppose that this is the region of the coast here. Let's suppose here also you have the coastline. So, these waters will have a drag because of the air. The air is going to drag some amount of surface water. I hope we can imagine that, because the wind movement is very strong. So that wind will be able to drag the surface water. So can I say or rephrase this in order to say that these winds, they will be carrying the warm water along with them. The warmest of the water will be carried by the winds. Can I say that? Yes, because the surface water is the warmest. This is the warmest layer. Now, as these winds, yes, I'm talking about permanent winds here. As these winds come across to this, is this till this portion, is everything being understood? Or is there a doubt in this? It is being understood. Okay, good. So here, as these winds, they come, they will accumulate these warmer waters here. They will end up accumulating these warmer waters, right? Now, as they accumulate all the warm water, what can I say about the temperature of this area? Will the temperature remain normal as compared to the other portions of the ocean? Will the temperature be higher than normal? Will the temperature be lower than normal? What do you think? The temperature will be warmer and higher because you have accumulation of all the warm waters brought by the wind. So, there is an increase in temperature. Increase in temperature. Comfortable with this? Now, in the meanwhile, the wind does not stop there. It continues to bring. It continues to bring more surface water. Now, where will all this water go? It will pile up, maybe increase the height of the water level in that area by around 8 centimeter or 10 centimeter. But a continued piling up won't happen beyond a particular proportion. So, if I say that this continuous movement of the surface water and accumulation of the surface water eventually will force the water to sink down. Can that be digested? That eventually, as more water is being brought by the wind, that water will be piling up But beyond a particular limit, more water is being brought by. So this will be pushed down in a way. Can that be understood? Good. This process where the water is pushed down because of accumulation of surface water by the wind, this process is what is known as downwelling. Downwelling. I will give you the definitions of this also. Don't worry about it. But just understand it. That these winds, they are continuously dragging the warm surface water. And those warm surface waters, they will accumulate and eventually they will all be pushed down. Because where else will the water go? Where else will this continuous bringing of water go? Because these are not stormy winds which can cause storm surges. If you have that perception that these will flood the land, these are not stormy winds. These are normal winds. So they will continue to pile up the water. At one point, the water will then be lowered down. It will be pushed down. So Pallavi, is it understood now? Or is it not understood? Good. Krishika, is it understood? Nikita, no. Krishika, yes. Where the space will come from? Okay. So basically, we are talking about water, guys. Water is a liquid. So if water is being pushed down here, that water will be distributed. The water which was present here, they will obviously be distributed somewhere else. It is liquid, it can move freely. So understand again, basically, when you have these warm surface waters dragged by the wind, imagine what can be, those of you who have not understood, imagine what can be the outcome of it. If all that water is getting accumulated and the wind is blowing continuously, what will be the outcome? Can you fathom a scenario if, let's suppose, this is the region of Pacific Ocean, if this is the extent of Pacific Ocean, let's suppose, here, here, winds are continuously dragging the surface water. Now, the surface water, which is the warmest layer, will start accumulating. But the winds are continuous. So what will happen to that water now? Where, and they are continuously dragging more water in this area. So what do you think will happen to the more water being brought by the winds? The winds are bringing more water on an hourly basis, on minute by minute basis. So what will happen to that excess water? Evaporation may occur. Okay. Evaporation, but is it the case that, let's suppose, millions of gallons of water are being brought by the winds? Now, all those millions of gallons of water will evaporate immediately? There will be evaporation, agreed. But as is the case with all the normal conditions, evaporation will happen at the same rate. Now, how could it be deposited if there is waves in water body? We are talking about the eventual downward movement. Water continuously has circulation. The ocean has got continuous circulations in various different areas. Water rises up in the lower latitude, sinks in the higher latitude. So water has got multiple circulations, multiple currents also in these areas. So yes, some water might get diverged here and here, but eventually much of that water will sink down. This is known as downwelling, when the water actually sinks down. So in these areas where the winds are bringing in the warm water, the temperature of the sea surface is going to increase. Now what about this region? this area, let's suppose. Now the wind has carried away the surface, the warm surface water. So there can only be two possible outcomes. If the surface water is being dragged away by the wind, there can only be two possible outcomes. The one possible outcome, maybe the level of water in itself reduces. The second possible outcome, if you remove that surface, then the lower subsurface will rise up and compensate, because we are talking about a water body, ocean. So if the warmer surface water is removed, the subsurface water will come up, or the level of water in itself will go down. So which of these things do you think will happen? Will the subsurface water come up, or will the level of water body in itself go down? What do you think? Yes, Krishika. Subsurface water comes up in this area. As the surface water is dragged away, the subsurface water comes up. Now subsurface water is colder. So what will happen to the temperature in this area? Temperature reduces. Now here what do you have? An upward movement of water. This upward movement of water, this is also what is known by the name upwelling. But basically, the temperature reduces. Here there is an increase in temperature, isn't it? So we have seen that in a large ocean, very large ocean, just by the virtue of movement of winds, just by the property and the phenomena of movement of winds, you can have different temperature attained at different ends of the ocean. With that basic factor, let us try to digest the Walker circulation. So first of all, let's suppose the equator. Now, around the region of equator, which is the wind system which is going to be prevalent around the region of equator? Wind system which is going to be prevalent? Trade winds. Very good. So these trade winds, they blow in which direction? Like this. In the northern hemisphere, they will blow like this. Southern hemisphere, they blow like this. Now, if I talk about the movement of these trade winds closer to equator, around the region of equator, let's suppose I talk about the movement of these trade winds. What is the direction of motion of these trade winds that you can see? If someone asks you about the direction closer to equator, what is the direction that you will say? Clockwise. How clockwise? I would want to know the answer, the reason for this. Why do you think it is clockwise? And which clock are we talking about, which does move like this? I want the answer to clockwise. Try to think of the answer and then let me know. Can we say that this movement is from east to west? A general direction of movement is from east to west. We can say that. Now, when you have a general direction of motion from east to west, and these winds moving over the vast ocean, the largest ocean in the world is the Pacific. Atlantic at equator is not so very thick, so very wide. Indian Ocean at the region of equator is also not so very wide. Pacific is very wide. So here, the winds will be able to gain momentum. They will be able to gain force. So they will be dragging the warmer waters. So eventually, they will be dragging the warmer waters, the surface waters. All that surface water eventually will get accumulated here. Surface water. So you have the warm surface water which gets accumulated here to the western part of the Pacific. Meanwhile, across the region of South America, the coastline of South America, as the surface water is being dragged away, surface water is being carried away by these winds, can we say that the subsurface water will come to the surface? And the subsurface water is colder, so colder waters will come to the surface. Colder waters will come to the surface here. Comfortable up till here? It is the same concept that we have studied in the previous slide. Comfortable? Good. So here, on the western part of the Pacific, you will have the accumulation of warmer waters. On the eastern part of the Pacific, you will have the subsurface colder waters which have come up. Now this warmer water, that will increase the temperature in this area. So this will lead to creation of what? Can we say that it will lead to creation of a low pressure? And here these colder waters will lead to a comparative high pressure. Now there is a pressure gradient force established. A pressure gradient force gets established between eastern and the western part of the Pacific. Established between eastern and western part of Pacific. Wind always blows from a high to a low. So you will have a wind movement from the high pressure to the low pressure. So here, the wind movement, the trade winds in themselves, they will get accelerated. They will all be moving towards that low pressure. And near the region of that low pressure will attract winds from all direction. Now here the winds will rise up. The winds, as they rise up, they will form those convective clouds, and they will cause copious amount of rainfall in this entire area, huge amount of rainfall. Meanwhile, the winds then will diverge. This is the upper air movement that we are talking about. Don't think that the winds are going near Hawaii now. No, it is the winds are coming towards that low pressure, rising up and then diverging. So as they will diverge, eventually it is around this colder air where you have the sinking. So that is where, and again, I hope this doesn't confuse you because we have talked about it in detail, that colder region is associated with the sinking of air. So that creates a vacancy in the upper air. So the wind circulation is obtained. We have looked at it in the previous earlier module. So here, basically, a circulation is achieved. Now, as a result of this circulation, can we say Western Pacific and Australia, and the region of Australia? By Western Pacific, I'm referring to the region of Philippines, Indonesia also. Here, they will receive heavy rainfall. Yes, there is convectional rainfall. Will experience heavy rains and Eastern Pacific or South American coast is going to remain dry due to the high pressure. Can we think about it like this? That the eastern coast, the eastern portion of Pacific will be drier, right? Now, this circulation that you observe, this is not happening between different latitudes. This circulation is happening at the same latitude across various longitudes, right? So this simultaneous development of two different pressure conditions is happening at the same latitude, right? So that is what is the Walker circulation. This will have its influence across. So here, the longitudinal circulation across the equatorial Pacific is known as the Walker cell or the Walker circulation. If you take a look at it, this is your entire Walker circulation in a nutshell. So where you observe the Peruvian coastline will experience high pressure, so fair weather and dry conditions. WX here represents weather conditions. So don't get confused what is this WX. So it represents fair weather and dry conditions. Now, the region of Australia, there, observe here by the way, there is a significant accumulation of warmer waters here. And here the colder subsurface water is rising to the surface. So that is basically where this will create that low pressure, cause significant amount of convective rainfall. So that is basically going to bring more amount of rainfall in the western portion of the Pacific as compared to the eastern portion of the Pacific. That is why the western portion of the Pacific is much more rainier as compared to the Peruvian coastline, as compared to the Western South American coastline. Okay, so the entire process of it. So trade winds blow from a general direction of east to west. Now the winds blowing over the vast expanse of the Pacific gain some speed. These trade winds tend to drag some amount of surface water along with them. These surface waters are warmer due to solar insolation. As these warmer waters accumulate, that creates the condition of low pressure, and this attracts winds, more winds, towards it, right? Creates a, an upwelling in eastern Pacific. That upwelling in the eastern Pacific creates high pressure, That high pressure will supply the wind now. So that creates dry conditions. Okay, where you have the warmer waters in the Western Pacific and colder waters in the Eastern Pacific. Full name of Walker, it was Gilbert Walker. He was given knighthood also, Sir Gilbert Walker. And full name of Walker, when was it given? When he was born, that is when his name was given as. Or are you asking about the Walker circulation when the name was given as Walker circulation? It was in the 1890s when that Walker circulation was developed. I hope that is what you are asking. I hope that is not you. You are not asking why his name was Gilbert Walker and when his parents gave that name. Okay, good. Amritansh, you have a question. Why upper air will move towards Peruvian coastline? Okay. So basically, it is from the same concept that we have studied. Let's suppose here you have the cold surface. Now, cold surface means the air will become colder, colder air will sink. That will create a vacancy here. This will come to fill that vacancy. That will create a vacancy in this portion. The air above will come and sink to fill that vacancy. Like that, air will be sinking in the region of the cold air. So if you have air coming in the upper troposphere, upper portion of troposphere, and there is a vacancy there, the air naturally has got a tendency to fill that vacancy. That is why cold surfaces are associated with sinking air. If tropical cyclone is observed in the Pacific region, can they escalate the intensity of the cyclone due to Walker circulation? Basically, when you have the case of Walker circulation, under normal circumstances, this is the circulation which is observed. So there, western part of the Pacific will automatically have the accumulation of warmer waters. So that is one of the reasons why the region of South China Sea and western part of Pacific, they experience more occurrence of tropical cyclones, much greater occurrence of tropical cyclones in this area. And the warmer winds, they will always, wherever they are going onshore, these warmer winds will cause downwelling, increase the temperature of that area, make it conducive for a tropical cyclone. Okay. Now here, this is the impact of the Walker circulation across the entirety of the planet. Here you observe that around the region of Western Pacific, you have that area of low pressure. Here you have the region of high pressure. Right. Now, observe that this arm of Walker circulation in the region of Western Indian Ocean and Arabian Sea, it will have its influence. You have a sinking air. Now, when you have a sinking air, the air is sinking from above. Can we say there will be high pressure, comparative high pressure? So, under these circumstances, where is it that a tropical cyclone is more likely to form? South China Sea, Bay of Bengal, or the region of Arabian Sea? Where do you think a tropical cyclone is more likely to form? Very good. Bay of Bengal and South China Sea region, because that is where you have this low pressure. At least high pressure is not there. And for the formation of a tropical cyclone, you do need a pre-existing low pressure condition. So that is basically how it will influence or impact the pressure condition. Okay, and the formation of cyclones. So under normal circumstances, That is one of the reasons why, under normal circumstances, Bay of Bengal is more conducive for formation of tropical cyclones. These are not the main points, but an add-on point. Okay, how uh, Bhimare? Here, ocean salt water evaporated and rain will fall on land. Rain will fall over water body also. Then we get fresh water through rain. So, can we get fresh water by evaporation of salt water? Obviously, yes. When you evaporate salt water, the salt is left behind. It is only fresh water which evaporates. So, if somehow you can trap that, that is the basic methodology which is used in desalination plants. Desalination plants, which provide the water supply to many of the desert regions, what do they do? Saline water is evaporated, the salt is left behind, and the water is then utilized for freshwater purposes. You told water move inside, but in Walker circulation, wind forming cloud. Previous slide, you told that water is moving inside. Where did I say that water is moving inside? Okay, okay, I understood. You're talking about this, Girish, are you? That you are comparing downwelling with the sea. Water is moving here, right? It is the downwelling that is happening. Here, what I am showing you is the air movement. It is not water which will rise up to form clouds. Can water ever rise up to form clouds? No. Here also there will be downwelling. Water will go down. Water will sink down. But then there will be a low pressure in this area. Because of the heating, there will be a low pressure in that area. So that will attract winds. And once the winds reach the region of low pressure, where will they go? They will eventually rise up, cause convective rainfall. Sir, but Arabian Sea also gets thermal insulation. It gets thermal insulation. But a pre-existing low pressure is not created in these conditions. I'll also show you conditions where, for example, during the conditions of El Nino, you have a low pressure created there in the Western Indian Ocean. So it is very conducive in Arabian Sea to lead to formation of cyclones. Vikalp, does it also shift with the shifting of ITCZ? Now, over the Pacific, think about it, you have a uniform ocean. So shifting of ITCZ is not very prominent. Had there been land areas in very close vicinity of the Central Pacific, the ITCZ would have demarcated a shift. But because Pacific is a very large uniform ocean, homogeneous temperature distribution, that is why ITCZ mostly lies around the region of equator. Okay, Vikalp? Ankush, sir, when dry winds return from Australia, these winds that I have demarcated, how many of us feel that we are talking about surface winds here? Any of us having that conception that it is the surface winds? No. So these are upper altitude winds. These are going to blow in the region of around the top of troposphere. That is why I indicated this image here. The trade winds closer to the surface will bring forward that warm water. Here, the trade winds themselves, the portion of the trade winds themselves, it is not as if trade winds will have a different color, and then when you have the convection rainfall, that will be of a different color. Here, the trade winds, the wind or the air which has reached this low pressure, that will also get heated up, that will rise, lead to formation of clouds and cause rainfall. Here, these winds are in upper atmosphere. This winds that you are talking about, this is basically the upper atmospheric movement. Is that understood? Or is there any doubt which prevails? Is that understood now? its upwelling and downwelling happens in every river? No, generally the oceans. Water circulation only happens in Pacific Ocean? Yes. So when we talk about upwelling and downwelling, first of all, the definition so that you have some relief in your hearts and minds. So basically, winds blowing across the ocean surface, they push the water away. Water then rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling, the upward movement of water. Upwelling occurs in open oceans and also along the coastlines wherever you have the offshore winds. Offshore wind conditions. Then, the reverse process called downwelling also occurs when the wind causes surface water to build up along a coastline, and then the surface water eventually sinks towards the bottom. That is downwelling. Now, upwelling can be beneficial also for the local economy and also for the marine biodiversity. Why? Is because of the fact that whenever you observe or experience upwelling, water from the lower regions of the ocean, they are brought up. Now, these waters generally are rich in minerals such as iron particles, etc., dissolved iron and other particles. Now, these minerals, they come closer to the surface. Closer to the surface, they get exposed to sunlight. So closer to the surface, now when you have the nutrients also, you have sunlight also, that is when you have a sudden growth or significant growth in the plankton population, the algae, the small microscopic organisms which produce food. So planktons, their population starts to increase. As the plankton population increases, they serve as food for many of the zooplanktons, the krills, their population will increase. Then the fishes will increase because they will get more food. So that is where it is good for fishes. You will have a great population of fishes or increase in population of fishes due to upwelling. So deeper, colder, nutrient-rich water rises up from beneath the surface to replace the water that was pushed away. So as it rises up, it brings the nutrients in the availability of sunlight. Plankton is able to carry out photosynthesis and thereby produce food, which is beneficial for the marine ecosystem. And that is what is going to lead to the increase in population of the fishes associated also. Okay. Now, after this, we come to the portion of ENSO, El Nino Southern Oscillation. Do you need a break now or are we good to go for some time? Do let me know. Okay. Okay. Fair enough. I'll take a break. And how long a break do you want today? 15 minutes. We'll do one thing. We'll take two breaks today. Okay. I understand it is morning time and it is a Saturday. So we'll take two breaks. So get a 15-minute break now, and then I will give you a 5 minutes break later on. Okay, a 5 minutes intervention break at maybe around 10:30 or around 11. I will give you another 5 minutes break. We'll continue till 11:30 if possible. I hope you are game for it. 11:30 or maybe even 11:45 if possible. Okay, so take a 15 minutes break now and get the things done. Be back in 15 minutes. A confirmation about the audio, please, if the audio is clear. Thank you. So now we come to the portion of El Nino Southern Oscillation, or ENSO. So basically, we have seen till now that under normal conditions, the Peruvian coastline will remain dry and the region around Australia, Indonesia, Philippines, they will end up receiving substantial amount of rainfall. That is something that we have gathered from the portions that we have covered till now. Now, when we say that Peruvian coastline will remain dry, now in the time of the southern summers, that is in this time period, November, December, January, February, these dry conditions, oftentimes, they are not very welcome. But basically, the dry conditions are there, so you cannot do much. Now, as the story goes, that once you had a group of Peruvian fishermen off the coast of South America, now during the time of December, around the time of Christmas Eve, that is when they experienced the sudden onset of rainfall. The sudden onset of rainfall occurred. And that was unusual for them. And that is when they thought about it to be the gift from Christ Himself. And that is where that event of rainfall in the Peruvian coastline, that was named as El Nino, or the Christ child. Now, because of a gift from Christ. But this did not happen every year. Every few years, the climatic conditions would be such, maybe every 3 years or after 4 5 years, like that, you would have the climatic conditions to be such that the region of Eastern Pacific would receive rainfall, and Western Pacific, that is the region around Australia, in those times would be drier. So the climatologists at that point of time, they thought about it, that look, there is a continuous change of climatic conditions from rainfall in Australia to dry conditions in Australia, from dry conditions in Peruvian coastline to rainfall in the Peruvian coastline. So there is a kind of a continuous oscillation from El Nino and the opposite of it. So that continuous change from El Nino and the other condition, that was termed as ENSO, or El Nino Southern Oscillation. That is something which was termed as ENSO. Okay. Okay, is there still an impact on the audio? Audio, is it working fine, or is there some issue with the audio, guys? Is there any echo or anything like that? It's working fine. Okay. So, so basically, they observed, or they came to a conclusion. At that point of time, not enough study had been done, but one thing was clear from observations on a day-to-day basis. That thing was basically that in the region of Peruvian coastline, sometimes there's a reversal of climatic conditions in such a way that rather than being dry, it would remain dry for 2 years, 3 years continuously, and suddenly 1 year Peruvian coastline would receive rainfall. And that year, Australia would be dry. Otherwise, again, it would revert back to the normal condition where the region of Australia would receive rainfall, and again, Peruvian coastline would remain dry. So they thought that the climatic conditions are oscillating between these two portions. And because it is happening immediately around the region of equator, slightly to the south in the southern hemisphere, that is why it was named as El Nino Southern Oscillation. Oscillation, basically, that from El Nino conditions to normal conditions, again El Nino conditions, again normal conditions, every 2 to 3 or 3 to 4 or 5 to 7 years, this would happen. Later on, when the climatologists, the oceanographers, they actually went there, they studied the region, they found out that wait, it is not only El Nino and the normal conditions. there is the other extremity to it as well. The other extremity is, one extremity is that Peru receives rainfall, Australia is dry. The other extremity is that Australia, Indonesia, Philippines, they receive much higher than normal rainfall as is caused by the Walker circulation. Very high amount of rainfall, much higher than even the normal Walker circulation. And the Peru coastline is much more drier, a stronger high pressure as compared to even the Walker circulation. So that is what they named as the opposite of El Nino, and it was named as La Nina. That is the girl child, the opposite of El Nino. So La Nina conditions would represent the situation when Peruvian coastline would be drier than normal, Australian coastline would be damper or rainier than normal, and El Nino would be the reverse of it. And in between them, you had the normal condition. So that is why in the region of eastern and western part of Pacific, you basically have the weather conditions oscillating between these areas. You have basically El Nino, La Nina, and neutral conditions. And the climatic conditions would basically vary from here. Sometimes they would go to the conditions of El Nino. Sometimes they would go to the region of La Nina. So there would be this continuous movement or change in climatic conditions from one type to the other. So this continuous changing, this is what is known as ENSO. El Nino Southern Oscillation. Now let us understand what these neutral conditions are. What is the condition of El Nino? What is the condition of La Nina? When does it happen? Why does it happen? El Nino is also what is known as, we will see later on also. El Nino is known as the warming phase of the Pacific. La Nina is known as the cooling phase of the Pacific, because Pacific Ocean is a very large water body, a substantially influential large mass of water body. Warming and cooling of the Pacific can significantly impact the movement of winds and air circulation above the region of the Pacific. When we talk about these neutral conditions, these are nothing but normal Walker circulation. Normal Walker circulation. Okay. So first of all, let us take a look at the neutral conditions, something that we have already seen. Then we will look at La Nina. Then we will look at El Nino. So neutral conditions basically means under normal circumstances, these conditions will prevail. Under normal circumstances, these conditions would prevail. Okay, so here basically in the case of the neutral condition, what happens? That is, it is nothing but a normal Walker cell, Walker circulation. So basically, under normal circumstances, trade winds would help accumulate warmer waters in the region of West Equatorial Pacific Ocean, while colder waters would emerge in the Eastern Equatorial Pacific Ocean. The upwelling. right? Upwelling would lead to colder waters in the eastern Pacific. This would cause heavy amount of rainfall in the region of northern Australia, while due to high pressure, the Peruvian coastline and the western coast of South America would be very dry, right? So that is the weather influence. So here, this is the case of the normal circulation, something we have seen in the case of Walker circulation also. Okay. Now, are we comfortable up till this point? Right? Are we able to follow? Any doubts till now? Very good. So now, let us build on this concept. One by one, let us apply logic and let us try to see what it can develop into. So, here, you see the accumulation of warm waters. Now, these warm waters will form a kind of a low pressure. Now, here you have the colder waters. That would represent the region of high pressure. So you have a pressure gradient force in existence due to which the trade winds also will blow. Now, once you have this low pressure and high pressure centers established, and as these winds continue to blow, can we foresee a situation where maybe in 1 year or maybe after many months of this process going on, can we foresee a situation where more surface water will be carried by the trade winds? Eventually, the trade winds will carry much more amount of surface water. They will continue to carry the surface water. Surface water is the warmer portion. So, as more surface water is dragged by the trade winds, can we fathom an increase in the area of this warm water accumulation? Or can we think about the fact that low pressure can get intensified? Intensified. With more surface water being brought towards this region because it is a low pressure, so winds will always be targeting that region. With more surface water coming towards this region, can we say that more warm waters are coming, so the condition of low pressure will get further intensified? Now, once that low pressure gets intensified, then what will happen? Can we say that will attract stronger winds? Yes, Shahid. Normal neutral condition is simply the Walker circulation. Can we say that the winds will get much more stronger? When the winds get stronger, what will happen? More surface water will be dragged. Water gets carried to Western Pacific. Can we say this that more surface water gets carried over to the Western Pacific? Right? Now, more surface water, more warmer water gets carried to the Western Pacific. Will this be not a feedback loop that it will keep on intensifying the low pressure? But there will be other implication also. The other implication will be as more surface water gets carried to the West Pacific, greater upwelling will happen in the east. Amount of upwelling will happen. When greater amount of upwelling will happen, so colder subsurface waters will come up in the eastern Pacific, also will start coming up in the region of the central Pacific because it is carrying the surface water much more strongly. So there what will happen? That upwelling will not only be restricted to the eastern Pacific, it will spread over almost to the entirety of the central Pacific also. So will lower the temperature in eastern and central Pacific. Comfortable up till here? Now, as it lowers the temperature in this wide area, we can say that high pressure will also get more stronger. Why upwelling in the central Pacific? Anjan, understand that earlier the trade winds which were blowing, they were carrying the water. So not some significant amount of water was being carried over. But when the winds would get strong, they would drag more water from the central portion also. Wherever possible, they would drag the water away. So everywhere that upwelling can happen. So the cold air, water region will expand. The warm water area will also expand. Warm water will get, or the low pressure area will get more intense. High pressure will also get stronger. A combination of this means what? Much stronger winds. Much stronger winds. High pressure is stronger, low pressure is intensified. So, what will be the outcome of it? Australia, Indonesia, Philippines, which would earlier receive rainfall due to the Walker circulation, now they would get very heavy amount of rainfall, higher than normal. Maybe floods will occur, flooding will be very common. And Peru and the South American coastline, which was dry, now that would also receive very heavy amount of dry conditions, or it would be very dry because the high pressure has got strengthened. So in a way, this is a Walker cell itself, but it is as if Walker cell on steroids, isn't it? Much stronger, much in more intensified Walker cell. This condition, which is attained, this is known as the condition of La Nina. So when you have La Nina condition, observe here, the warm water, the extent of low pressure in the Western Pacific is much stronger now. And look at the regions where that upwelling has brought the colder waters. In this entirety of the area, now you only have the presence of colder waters. So what does that lead to? We can say that it is a cooling phase of the Pacific, where the temperatures of the Pacific Ocean in the central equatorial Pacific, the eastern equatorial Pacific, they have reduced. Now the weather condition, Australia will receive very heavy amount of rainfall. Very, very heavy amount of rainfall. Now here upwelling has occurred all along the region because of the strong winds. Upwelling has occurred. And there is piling up of the warm waters in this entirety of the area. You know, when this La Nina event occurs, or even under normal Walker circulation, generally the height of water level in the Western Pacific, it is around 8 to 10 centimeters or 7 to 8 centimeters higher than the Eastern Pacific. 7 to 8 centimeters ideally would be this much, right? But think about it, that when you are talking about a water body, even this much temperature difference or this much height difference is quite significant. So when we talk about La Nina conditions, this is basically a strengthening of the Walker circulation, intensified case of Walker circulation. So La Nina conditions, they develop They are the conditions where a significant low pressure develops across the western equatorial Pacific Ocean, while an intensified high pressure develops over eastern equatorial Pacific Ocean. In a way, it is nothing but an intensified Walker circulation. It leads to flood like conditions across northern Australia, while leading to drought like conditions across the western portion of South America. That is the condition of La Nina. Now, before I move to the next slide, I want to take you back to the older portion of Walker circulation that we had studied. In the case of the normal Walker circulation, observe the water. Water is something I want you to observe. Now, here, if you observe, there is some amount of warm water accumulation. Here, upwelling is something which is common, right? That is something that you can observe here. Now, compare it to the condition of La Nina. Compare this to the condition of La Nina. Warm water proportion has gotten significantly higher up. You can actually look at the difference in water level, slight difference in water level will also be there. So here, the cold water has basically almost come to the surface. In the older image, if I can take you back to the older image, here, let's suppose, in the older image, this is the normal Walker circulation. Observe the Peruvian region, observe the Australian region. Now, if I take you to this particular portion, there is a difference, right? Because the winds have become stronger, they are carrying more waters, and that is why you have this condition. La Nina generally is conducive for rainfall in India. La Nina has got a positive influence. It tends to increase the amount of rains that we receive during the monsoon period. Why and how? We will study when we study the Indian monsoon in the next module. Okay? Even El Nino, why and how, Indian Ocean Dipole, why and how do they influence the Indian monsoon? Everything we will study in the next module. But as of now, just remember this fact that La Nina tends to accelerate the amount of rainfall, increase the amount of rainfall received in India during monsoon. So La Nina is beneficial for us. Now, here, let us have some logical understanding of what is happening. Let's suppose I have a tub. Meaning of Darwin and Tahiti. See, I won't be able to tell you the exact meaning of them, but I can tell you that Darwin is the coastline of the region of Australia, and that is what is represented here. And Tahiti is a island in the region of Central Pacific, and that is what the name here represents. It tells you the weather conditions in Tahiti and the Darwin coastline and the Peruvian coastline. But what is the meaning of the word Darwin? That is something I am not aware. It is basically Charles Darwin, from his name it is taken. So if there is actually a meaning of it or not, I don't know. So I don't know if you were asking about are you asking about the literal meaning of Darwin and Tahiti? In that case, I don't know. But what these represent the coastal areas. No, you were not asking the meaning. Okay, fair enough. The question basically was framed like that. Sir, much stronger winds in high pressure means you are saying the dynamic winds. Why? Why do you think that the stronger winds around the region of high pressure will represent dynamic wind conditions? You are thoroughly confused between thermal and dynamic wind conditions. From the previous couple of classes, I am observing this trend. Dynamic pressure is when you have the creation of a high or low pressure independent of the temperature on the surface. That is the dynamic condition. Other than that, if you have the formation of a low pressure, high pressure because of temperature condition, that is a thermal pressure. Anywhere, if temperature influences the pressure of a region, Forget the winds for a brief moment. Anywhere where the temperature influences the pressure conditions, that is a thermal pressure. Anywhere where you will have the only the temperature or the pressure which is independent of the temperature on the surface, that is the dynamic condition. In this region or in this situation of La Nina, don't we have cold waters in the eastern and central Pacific? If you have colder waters, that creates a high pressure. So this high pressure, is that high pressure created because of the wind? That high pressure is created because of the cold water. Let's suppose the wind would be moving and it would not be able to carry out any upwelling. Then what? So this high pressure or low pressure is because of the property of the sea surface. Sea surface, when it gets warmer, it will get low pressure. Sea surface here, when it is getting colder, it will create a high pressure. Is that getting understood? Is that understood? Yes? So I hope there is no longer that doubt between thermal and dynamic. Why there is an increase or decrease in pressure which causes. See, understand. Basically, Anjan, what we are trying to say here is the fact that sometimes it can happen that warm water is already accumulated. Now, this is a low pressure region. Low pressure means it will continue to attract winds towards itself. As winds keep on getting attracted, they will drag more surface water, isn't it? So, more surface water are dragged means what? This warmer portion will get more warmer because surface water is the hotter one. So more warmer waters are being carried away. So what will happen to the condition of the low pressure? Low pressure will get stronger, will get intensified, which will attract more stronger winds. More surface water gets carried. Low pressure will get further intensified. Now more surface water is carried to the region of the Western Pacific because of the stronger winds. Why did the winds become stronger? Because the low pressure got intensified. Why did the low pressure get intensified? Because these winds slowly and steadily over the period of 1 year, 2 years, or many months altogether, they would continue to pile up this warm water. And low pressure would always attract wind, so more warm water would come to that area. So eventually, the low pressure would get significantly intensified, winds would get stronger. When you have stronger winds, that means in these areas, if the winds are getting stronger, there will be upwelling in this area, which will be very common. So colder water region will increase, it will get more intense, a stronger high pressure, right? So that is where you will have the high pressure also strengthening, the low pressure also strengthening. So in a way, the entire circulation gets significant boost or significant amount of strengthening. Is that now understood? Rani, is that understood now? Yes? What is the basic difference between El Nino and La Nino? First of all, it is not La Nino, it is La Nina. And have we studied about El Nino till now? Then how can we come to the difference between what is El Nino? Have we studied about that? So kindly wait, have patience. Pooja, the La Nina and triple dip La Nina, both are same or are different? So basically, when you have La Nina conditions, again, these do not end up continuing for a long time. Maybe for 1 year, after that, it can return to normal Walker circulation, or it can get changed to El Nino conditions. But sometimes, which is very rare, which happened during the period of 2020, 2021, and 2022. In these 3 years, you had the continuous occurrence of La Nina. So, because you had that continuous occurrence of La Nina, it was known as the triple dip La Nina, which is very rare. It does not happen very frequently. That is the recurrence of La Nina year after year. Okay. Now, after this, let us understand one very basic concept which will help you understand the entire process of El Nino also. Now, here, let's suppose let's suppose I have got a large bucket or a large tub, and I have filled it with water to the brim. Let's suppose I filled the water to the brim. Now, here on one side, I have installed a large fan which is moving very strongly. And this is basically driving very strong air movement here. Now you have the surface or the bucket which is or the tub which is full to the brim. Now, will the water stay undisturbed, or due to this air movement, can we expect a situation where this water will get dragged by the air? If you have never seen that, try having a blow dryer or a fan on top of the bucket of water. You will observe that water gets impacted. Will we expect a kind of a piling up of water here? Maybe some portion of that water spills over. Can we expect that? Yes or no? Yes. So that is a possibility which will happen, right? When you have this fan which rotates, it gives up the air. Then that water eventually gets pushed to the other side and some of it will spill over. Now, let's suppose you switch off this fan. You switch off this fan, the air movement will also stop. Now, what will happen? Will the water continue to remain dragged over to one area and continue to remain in that lopsided state? Or will that water flow back and maintain an equilibrium? What do you think will happen in this case once the air movement has stopped? It will retreat, it will flow back, it will maintain equilibrium. So, we have come to a conclusion here that if the air movement stops, there will be the air movement which was responsible for that accumulation. If that air movement stops or weakens, there will be a flow back, isn't it? Let us write it down somewhere so that it is easily understandable. So, representing the same thing. So, all the water which was here, which had accumulated in this portion and was even spilling over, in the case of the wind movement or the air movement, water flow back of water is observed when the wind movement stops. or weakens. Now, this is not a simple bucket experiment that I want to talk about. Here, it has got implications. Implications where? For example, when we talk about the Pacific Ocean, you have that accumulated water. In the case of La Nina, or even in the case of the normal Walker circulation, accumulated water is present in the Western Pacific. And which is the wind which is keeping that water accumulated in the Western Pacific? Which is the wind which is responsible for keeping that water accumulated in the Western Pacific? Excuse me. Good. Very good. Trade winds in Western Pacific accumulation of water is maintained by the trade winds So here the winds that in the example that we have seen, the winds representing the fan movement or the winds due to the fan, trade winds replicate that in terms of the principle. Now, for this bucket example, the supplier of wind system was this fan. Okay. For this bucket example, the supplier of the wind system was this fan. Now, for the trade winds, which is the supply source of trade winds? What is the supply source of trade winds? Coriolis force. So Coriolis force leads to the supply of trade winds. Then why are trade winds not found in the polar areas? Good, Sakshi. Anjan, correct. Very good. Can we say that subtropical high pressure zone is the supplier of the trade winds? Can we say that? That subtropical high, not any high pressure, not a normal pressure gradient force. Can we say that the creation of a subtropical high is the supplier of the trade winds? Can everybody agree on that? Yes? Understand one thing, Coriolis force is never going to be the supplier of winds. Coriolis force is never going to initiate the wind motion. Any wind motion will be redirected because of the Coriolis force. That's it. Coriolis force is responsible only for the change in direction. It can never lead to the initiation of the wind movement. If that would have been the case, then wind movement would have happened anywhere and everywhere because Coriolis force is present across the planet. So basically, the supplier of the trade winds is the subtropical high pressure. Particularly in the Pacific, you have the Hawaiian high. I hope you recall what we have studied in the 7th module. The region of the Pacific Ocean has got the presence of Hawaiian high. So here are supplied in the Pacific Ocean are supplied by subtropical high pressure in the region of Pacific by Hawaiian high. Now, this Hawaiian high pressure, is it a thermal high pressure or is it a dynamic high pressure? Let me know. Good. Very good. A thermal high pressure is created when? When is a thermal high pressure going to get created? When the temperature is very low. When the temperature is very cold, that is when a thermal high pressure will get created. Have we completely disconnected, guys? Is it the case of the Saturday morning or is it something else? Have we disconnected completely? Because if that is the case, these are important portions. If you don't understand this concept now, that is something which will be very, very difficult. Thermal high pressure is basically when you have very cold conditions on the ground, high pressure which is created. Thermal high pressure across the planet is created in the polar regions. Okay, this is a dynamic high pressure. Okay, this is the case of a dynamic high pressure. Dynamic high pressure means pressure created due to sinking of winds. Due to sinking of winds. See, if you don't revise that tricellular model of circulation, these things will be very temporary. All these portions will remain in your mind for a very temporary duration. I can give that in writing, that by the end of the next week, everything will be forgotten. That is why I keep on harping it and I won't repeat it anymore. But if you don't revise, this is not a subject that you would associate like your polity or your history. That is what I told you in class one, first session also. This is not your normal subject like a polity lecture or a history lecture, where in polity, let's suppose you have missed the portion of preamble, but union, executive, and legislature you will be able to follow. Even if you have missed the portion of union, executive, and legislature, you won't have an issue in following the portions of the Supreme Court. And you will be able to pick up from anywhere that you left off, and you will be able to follow. In history, you have not understood or you have not read about 1857 revolt, still Canal revolt and Kuka rebellion will be understood, because it is a different thing altogether. In the if let's suppose non-cooperation movement you have missed out, civil disobedience movement is a new event altogether. You won't have any problem in understanding. In the subject of geography, if you have not understood the basics, these complex phenomena will never be understood. Never will be understood. You can take that in writing. You can ratify it. You can rote learn it. That many of the candidates, they take that path eventually. But that is short-sighted. It will cause negative errors, negative markings. That is why always I say, right now, I'm not saying you to revise the portion of geomorphology. I'm asking you, you should have ideally, before coming to the session, you should have revised the portions of at least the tricellular model of atmospheric circulation. Nonetheless, we move ahead with whatever we have. So basically, when we talk about the dynamic high pressure, this is a high pressure which has been created because of the sinking of the winds. Now, let us understand this. What happens? So here, if let's suppose this dynamic high pressure, if this high pressure weakens or becomes inactive temporarily. Can we say that trade winds will also get weakened or will disappear? Will also weaken or disappear. Can we have this conclusion? That because the supplier of these trade winds is a subtropical high pressure belt, in the Pacific Ocean, it is the Hawaiian high. If that Hawaiian high weakens or temporarily that high pressure does not exist, the trade winds will also weaken or disappear. Now, the question arises is the fact that why is it that this high pressure will weaken or why is it that it will temporarily disappear? So, let us understand this. Now, let us consider this to be the Pacific Ocean. Now, every year, you have warming, cooling of the Pacific Ocean. Now, whichever region that you are living in, whichever area that you are living in, do you experience the same temperature in every summer? Or is it the case that sometimes the summers are much warmer? In certain years, the summers are much warmer than the previous year. Next year, you might have the condition, or this year, you might have the condition where the summer was much warmer than the previous year. The winter is much colder than the previous year. So, obviously, you don't have the condition where it is consistent temperature throughout the each year will have the consistent temperature. That is not the case. Every year there is sometimes greater warming, sometimes there is greater cooling. Let's suppose there is a greater warming of the Pacific Ocean over a period of maybe 1 year, 2 years, 3 years. It has warmed up very significantly. Now, in this area, you have the dynamic high pressure. So you have the sinking of the air column, which induces that dynamic high pressure. Now, in the years when the Pacific warms up significantly, then what will happen? Can we say that from the region of the water, because the water temperature will go up, so air above it will also start to get warmer? I'm talking about the subtropical high pressure zone. Subtropical high pressure zone. Now, as the water gets warmed up, can we say that the air above it will also get slightly warmer? So this air, because it is warmer, it will have a tendency to rise up. It will have that tendency, whether it is able to rise up or not, that is a different proposition altogether. But it will have a tendency to rise up. And as it has got the tendency to rise up, it will meet the sinking air. Now, what will be the impact of pressure or impact of this on the pressure on the surface? Earlier, you only had that sinking air. So you had that high pressure. Now you have the air which has warmed up and has tried to rise up, right? It is trying to rise up. So can we say that the high pressure weakens or it can temporarily get inactivated as well? So when that high pressure weakens or gets temporarily inactive, the trade winds they become discontinuous and the trade winds become inactive. Now, when the trade winds become discontinuous or inactive, there is nothing to hold that accumulated water in the Western Pacific anymore. And that is when the water of the Western Pacific starts to simply flow back. And when that water of the Western Pacific flows back, because it is an accumulated one, just like in the case of the tub example. Now, here the trade winds have weakened or disappeared, so it will start to flow back. When it starts to flow back, and why it starts to flow back? Because of heating of the Pacific. Because of the heating of the Pacific, the dynamic high pressures, they have weakened, right? Dynamic high pressures, they are not that strong anymore. And they are the drivers of the trade winds. So the trade winds have weakened. So now they won't be able to hold that accumulated water. It will flow back and it will come to the region of Eastern and Central Pacific. Now, that is where the El Nino events will happen. So basically, warming of the Pacific weakens the high pressure, which weakens the trade winds. Induces a flowback to the Eastern and Central Pacific. Okay. Now, this flowback which is induced, that basically brings forward the conditions of El Nino. So basically what happens in this case, here, let's suppose this is the equator. Now all the warmer waters which were present here, now these warmer waters will have a kind of a flowback associated. They will start to flow back. Why? Because the trade winds have disappeared temporarily. And this warmer water will start accumulating now or will come to the region of Eastern Pacific around the Peruvian and the South American coastline is where they will come. So the warmer water which was present here has actually flowed back, has reverted its movement, it has flowed back. Now here you have the condition of warmer waters coming into the region of Eastern Pacific. So this warm water will increase the temperature higher than normal. So this will create a low pressure. A creation of low pressure means winds will be attracted towards this now. Winds will get attracted towards this. They will rise up. They will form convective clouds. And that will bring heavy amount of rain in the coastline. In the South American coastline, this is going to induce a heavy amount of rainfall. Meanwhile, as these winds are coming, can we say that they will drag the surface, they will continue to drag the surface water along with them? Now, when they are dragging the surface water, in the western end of the Pacific, you will have colder subsurface water emerging due to upwelling, right? So, colder subsurface water will emerge due to upwelling. So, you will have a high pressure region here, isn't it? So, now the wind circulation overall can be thought out to be something like this. Okay. So, this is the condition of El Nino now. Now, El Nino basically will bring rainfall in the coastline of South America, will create very dry conditions in the region of Australian coastline. That is the characteristic, that is the nature. Now, here we do know that when we talk about these conditions of El Nino, they will not only impact the climatic conditions here, they impact India also. While La Nina creates higher than normal rainfall in India, El Nino creates scarce rainfall or lesser than average rainfall in India. El Nino influences the Indian monsoons negatively. Right. Now, in the region of Australia, basically all these phenomena of warming, cooling of Pacific, etc., that is very dominant in the southern summers. That is the summers of the southern hemisphere. In these particular months is when the Pacific in the southern region will warm up significantly. And then it is the summer season in Australia. And if you have conditions of El Nino, means dry conditions, lack of rainfall, it creates drought-like conditions sometimes in Australia. It can also lead to the raging of wildfires, of forest fires. They become a commonality in the region of Australia. Okay, so that is the case of El Nino. So El Nino is can be simplified to say it is a reversal of normal Walker circulation induced due to the flow back of water from Western Pacific to the east. Okay, that is the characteristics or the conditions of El Nino. Now here, when we talk about El Nino, it will also have a circulation across the entirety of the planet, just like the Walker circulation, just like the La Nina. So if I take you to the circulation of La Nina, observe why La Nina was referred to as the cooling phase of the Pacific. Observe the colder waters here. Upwelling has happened in this entirety of the region. The warm water region is very intense. So here, there is a sinking air in this region. Again, La Nina conditions are more conducive for occurrence of cyclones in South China Sea and Bay of Bengal. Beneficial for rains in India, first of all, for monsoonal rains in India, more probability of tropical cyclones in Bay of Bengal, South China Sea, region. Okay. El Nino, on the other hand, is basically the reverse of it. If you observe this El Nino condition, you will observe that under the normal circumstances or the Walker circulation, the strong winds would have accumulated a significant amount of warm water. But as the trade winds they weaken, observe how all of this will start moving in the opposite direction. Right? So it is a kind of a flow back. So due to weakening of the trade winds, the accumulated water across the western Pacific starts to flow back, leading to redistribution of warm and cold waters. Due to this, there are changes in weather conditions leading to drought-like conditions in Australian coast while causing floods across the Peruvian coast. So the Peruvian coastline receives heavy rainfall. This is disadvantageous or detrimental for monsoon rains in India. Reduced amount of rainfall is received in India. Now, this is the circulation. So that is why this is known as the warming phase of the Pacific. So here observe that you have a rising air and you have the sinking air here, creating high pressure, right? You have a low pressure condition created in the southern Indian Ocean also because of this, right? Warmer waters are created because of that. So it reduces the amount of rainfall received in India during the monsoon. How and why? We'll study in the next module. Here, basically, what you can see is the impact based upon the chart. So in 2004, we had an El Nino year. India received only 88% of the expected amount of rainfall. In 2005, we had a neutral condition. So that is when the rainfall returned to normal. We received 101% of the rainfall. 2006, the neutral conditions prevailed, continued. We received 103% of the rainfall. 2007, that neutral condition intensified into La Nina. India received excess rainfall, 110% of the average rain. 2008, La Nina prevailed, but it started getting weaker. We had 105% of the rains. 2009, it reverted, oscillated to El Nino. So observe, El Nino has occurred after how many years here? After 5 years, right? Severe drought, 79% of the rains, very dry conditions. Then 2010, La Nina, again, 100% of the rainfall. 11, La Nina prevailed again, 104%. Like that, you have had the conditions. In 2020, we basically had La Nina. We received high amount of rainfall, roughly around 100 to 103%. 2021, La Nina continued. We received close to around 109% of the expected rainfall. 2022, La Nina still continued. That is why it was referred to as the period was referred to as the triple dip La Nina, because it continued for 3 consecutive years. And then in 2022, La Nina was already weakening. 2023 was the year of the beginning of El Nino. This was the year of El Nino. So we received a slightly deficient amount of rain. And then next year, the El Nino, or this year, 2024, the El Nino is supposed to get stronger. So this year already, the meteorologists, the climatologists, they are predicting less than average rainfall in India. This is one of the major headwinds, one of the major challenges for Indian economy. Because when India receives less than average rainfall, crop failures happen. Crop failures happen means there is rural impoverishment, a fall in rural demand. That will impact the urban supply. That will impact the job creation. Unemployment rates go up. So that is why El Nino is always countered as a major factor during the budgetary years, during the formulation of policy measures, that what needs to be done, what interventions need to be brought by. Okay. Now here, then let us take a look at the question. So I'll do one thing. I'll give you 1 minute here. Read the question and get the answer. La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? Two statements. One of them is going to, or which of them is or are correct? Lakshmi, El Nino and monsoon table important for exam. If I say so, will you learn the amount of rainfall that India received since 2004? Will you be able to learn that? Then why that question? Khushi, can cyclonic conditions occur in Arabian Sea due to El Nino? Yes. Majority of you have committed the mistake, because of which I had given the 1 minute time period. So, good to see. This is the trap that UPSC expects you to fall into. So, you're not disappointing UPSC. So, here, that is why I said read the statements carefully. La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in equatorial Pacific Ocean. Have we even studied Indian Ocean till now? No. Had UPSC placed Pacific here, the statement would have been correct. But this is what UPSC relies upon on the candidates, that they will ignore this one word. They would see the overall sentence appears to be correct, so they would ignore this. And that is what most of you appear to have done. So this is incorrect. La Nina is characterized by cold temperatures in the Pacific, and El Nino is characterized by warm temperatures in Pacific. El Nino has adverse effect on southwest monsoons of India, but La Nina has got no effect on the monsoon climate. Clearly incorrect. La Nina brings increased amount of rainfall. So here, which of them are correct? The answer is D. Neither one nor two. Is that understood? Right? Now, after this, we move to the portion of Indian Ocean. Even though many of you have already marked that portion of Indian Ocean in the previous question, but let's move to the Indian Ocean now. Here, Indian Ocean is not as wide as the case of the Pacific. Here, but before coming to that, one point which was raised by Shreyas, and that is something that you also need to take into consideration. Due to global warming and the rate of global warming getting higher, which of these events amongst the Enzo cycles will be more common? Neutral circulation, El Nino, or La Nina due to global warming? It will be El Nino. Right, always El Nino, because El Nino is associated with the warming phase of the Pacific. So that is why the El Nino conditions will be much more frequent. Earlier, El Ninos and El Nino events used to have their occurrences once in 5 years or once in 7 years. But now you observe this process repeating itself once every 2 years or 3 years. So their frequency has increased and their intensity has also increased. That is not good for a country like India, which experiences lesser rainfall during the conditions of El Nino. Now, then we come to the Indian Ocean dipole. When we talk about IOD or Indian Ocean dipole, here, Indian Ocean, even though it is not as wide as the region of the Pacific, but Indian Ocean also can experience different rate of heating at the western end of the Indian Ocean and the eastern end of the Indian Ocean. That can always happen. Sometimes, when you talk about the region of Horn of Africa, that represents the western portion of Indian Ocean, the region of Horn of Africa, the Arabian Peninsula, sometimes they will represent very high temperature. So, they will heat up the water bodies close to it also. So the Western Indian Ocean gets heated up. But under normal situations, when you consider the Eastern Indian Ocean, you are considering about the water across the Indonesian coastline. Now, water across the Indonesian coastline will anyways generally be warmer. Why? There's a very basic fact behind it, or a very basic principle behind it. And that is the fact that there you have thousands of islands. In the Eastern Indian Ocean, you basically have thousands of islands. Now, water is trapped in between the islands. It is not as if water is circulating freely between the islands, no. Water is trapped in between the islands. So when these islands they get heated up, when these islands they get heated up, obviously land gets heated up. The water, which is not circulating freely between them, they will also indicate some heating. So normally, you will observe that across the Indonesian coastline, water is slightly warmer, maybe by 0.5 degrees Celsius, maybe by 0.2 degrees Celsius, slightly warmer as compared to the water in the Western Indian Ocean. Okay? Now, this difference in the rate of heating because of the influence of the landmass, because of insolation, this difference in the rate of heating at the equatorial Indian Ocean at the two ends, at the two poles of Indian Ocean, that gives rise to a competitive low pressure and a high pressure. Winds will blow from a high to a low. So as these winds will blow towards the region of low pressure, they will induce a kind of a circulation in the region of Indian Ocean as well. So that is the case of the Indian Ocean dipole. This also has got three distinct phases. One is the normal or the neutral phase. Or neutral phase. Another is the negative phase. Another one is the positive phase. So here also, it keeps on varying. It does not happen over a 1 year time period. It can happen over maybe every month or every 2 to 3 months, it can change. Right? So, Indian Ocean dipole is also called the El Nino of the Indian Ocean. The Indian Ocean dipole is basically defined as the difference in temperature between two areas or the poles, hence the name dipole, poles or the two opposite areas of the Indian Ocean, a western pole near the Somalia coastline, that is the portion of the Western Indian Ocean, and the eastern pole in the Eastern Indian Ocean south of Indonesia. So, difference in temperature in the between the Somalia coastline and the region of Indonesia. But why will that difference of temperature occur? So, here IOD or Indian Ocean dipole is a sea surface warming phenomena with different regions of Indian Ocean heating up to a different rate. Now, that differential heating can be the properties of the heated landmass nearby. maybe the Somali landmass or the region of Arabian Peninsula, they get excessively heated up. When they will get excessively heated up, they will have an impact there, right? The nearby water body will also get heated up. Prevailing wind patterns can accelerate or reduce the rate of heating. Oceanic circulations can also impact. So this, whenever you have a differential heating, different temperatures at the two ends, this induces a thermal pressure difference across the eastern and the western end of the Indian Ocean, right? And which in turn initiates an atmospheric circulation at the central Indian Ocean. Now remember, in the case of El Nino, La Nina, we had seen that this circulation reaches the portion of Indian Ocean also. But what if Indian Ocean has now got its own circulation? That will counteract the impact of El Nino. That is why Indian Ocean dipole can oftentimes be seen to be counteracting or even accentuating. Counteracting, I hope we know the meaning. Opposing, accentuating, I hope we know the meaning. Exaggerating, accelerating. So that is why you will observe that this Indian Ocean dipole can nullify the impact of enzo cycles or can accelerate the impact of enzo cycles. So, first of all, let us understand this. So, here, let's suppose, first of all, we draw the equator. Okay. Now, this is your equator. Under normal circumstances, under the normal conditions, this portion will be warmer. This is different from Western Pacific, by the way. Don't get confused between Western Pacific and Eastern Indian Ocean. You have lot of land and water in between. Under normal conditions, because water here is trapped between the islands not having sufficient motion, this will slightly get warmer. So here, under normal conditions, there will be development of a kind of a low pressure. Now, low pressure means winds will be attracted towards this. It will rise up, form clouds, cause rains in this area. Now, this low pressure can sometimes extend even to the region of Andaman Sea. And there, if you have this low pressure, it can lead to the generation and the rise of a tropical cyclone. Right? So, Bay of Bengal will experience tropical cyclones under normal conditions of IOD. Meanwhile, as these winds are getting attracted, there will be upwelling caused. Where? In this portion, there will be upwelling caused here. Colder subsurface water will emerge to the surface. So here there will be a competing high pressure, comparative high pressure rather. So here, now you have a circulation. This is your normal condition of IOD or the neutral condition of IOD. So when we say the neutral phase of IOD, that is when you will have that low pressure or the warming of the Eastern Indian Ocean. And a high pressure will develop due to upwelling in the region of Western Equatorial Indian Ocean. So that is what will bring up a circulation. Now, this is disadvantageous or detrimental to Indian monsoon, causes less rains in India. Now, here, trade winds over the equatorial Indian Ocean are not very consistent. We'll study it in the portion of the Indian climate that trade winds over the Indian Ocean are not very consistent. Now, it can happen every few months. Basically, if you observe the data repository of Indian Meteorological Department, they carry out this reading on a daily basis. That is the temperature of the Eastern Indian Ocean and Western Indian Ocean. So every few months also it can change. Every few weeks also it can change. Okay. Now apply the logic here. It is about which condition is prevalent at the time of Indian monsoons. At the time of Indian monsoon, if it is neutral phase, less rainfall. Negative phase, even lesser rainfall. Positive phase, higher than average rainfall in India. Now here, the same logic that we applied from Walker circulation to La Nina, apply the same logic. The winds, they keep on blowing towards this low pressure. Warm surface water will be carried over to the region of the low pressure. Low pressure can intensify, winds will get stronger, there will be more upwelling in the Western Indian Ocean. Western Indian Ocean will be much colder now. So Eastern Indian Ocean will be much warmer. So it is an intensified neutral phase that is known as the negative phase of IOD. This negative phase of IOD will be conducive for occurrence of cyclones where Arabian Sea or Bay of Bengal, where you will find more occurrence of tropical cyclones in this phase. Arabian Sea or Bay of Bengal? Bay of Bengal, right? So as you have seen, in neutral phase of Enzo, in La Nina condition, more likely to have cyclonic circulations in Bay of Bengal. In the normal phase of IOD, in the negative phase of IOD, Bay of Bengal is more likely to have development of a cyclone. These are side factors. Okay. Now, this is also causes less than average rains in India during monsoon. Does IOD influence Australian monsoon? Absolutely yes. Yes. The negative and the neutral phases of IOD are beneficial for the Australian monsoon. But Indian monsoon, they are not beneficial. Now, sometimes what can happen is that the region of Horn of Africa, the Arabian Peninsula, etc., that region can get very heated up. Sometimes that can happen, that the area of Horn of Africa, Arabian Peninsula, they get extraordinarily heated. As I told you, not every year will you experience the same temperature in the region that you are living. The temperature experienced will vary, right? So not every year will you experience the same heating and cooling in the Horn of Africa and the Arabian Peninsula. Sometimes it is much more heated up. When it is much more heated up, then it will heat up or warm up the region of water close by it. And that is when the Western Indian Ocean will get heated up as well. This will create a low pressure. This will create a low pressure, which will attract winds from all directions. And this will create upwelling and colder waters in the Eastern Indian Ocean. Anyways, the water is a bit cooler in comparison. That is why the low pressure and high pressure. So that is what is going to drive the positive phase of IOD. This positive phase of IOD is beneficial for monsoons in India. You know, how did we find out about this? That one thing can be beneficial, one can be disadvantageous, and whether they can counteract the impact of El Nino. So, before that, just think about it. If you have the conditions of La Nina, along with that, if you have a positive IOD, means much higher than average rainfall in India, maybe 109, 110%. If you have La Nina, along with that, you have negative IOD, that means around 100%, 101% of the average annual rainfall. Not very high because they will be cancelling out each other. If you have El Nino, and negative Indian Ocean dipole, you will receive drought like conditions in India, around 75, 79, 80% of rains. If you have El Nino and cancelled by a positive IOD, you expect somewhere around 97, 98% of rains in India. So they cancel out each other. It was actually a chance discovery about their overall impact, because it was understood for a long time that they have this phenomena. But in 1997 it came to the fore very apparently, because 1997 and 97, 98, that was considered to be one of the most extreme phases of El Nino, or one of the most extreme heating phases of the Pacific. In that year, the temperature in the Pacific rose abnormally high. Now, when you had that condition or that situation, basically, India was preparing itself for one of the worst droughts of the century, because it was going to be the strongest El Nino year of the century. So, India was bracing itself for a very strong drought like condition. But then what happened was basically India received normal rainfall rather than a drought. Then, upon further investigation and finding, it was found out that you had El Nino, but you also had a positive IOD. So that cancelled out each other. It is only lately that we have found another phenomena, that you have a traveling pressure belt system also. That traveling pressure belt, that low pressure system associated with high pressure systems, they travel also across the planet. On top of this, Enzo cycle and IOD, and that is the Madden-Julian oscillation, which also influences the amount of rains that you receive in India. Right. So here, first of all, take a look at the question which has been framed. Again, I will give you 1 minute. Read the statement, be better than last time, and get the answer. Good, Shahid. Ankush, wrong. Good. Majority of you have given the correct answer. Very nice. So here, at least you have taken the or looked at the catch. IOD phenomena is characterized by a difference in sea surface temperature between tropical Western Indian Ocean and tropical Eastern Pacific Ocean. Very specific, Eastern Pacific, Peruvian coastline. IOD is Eastern and Western Indian Ocean. So understand, that is why you study PYQs. You read PYQs to observe or catch the trends by which UPSC is trying to trap you. If I take you back to the earlier question here, if I take you back to this question, only one word was incorrect, rest of the statement was correct. Observe how UPSC plays the same trick again. Only this word is incorrect, rest of the statements is correct. So that means UPSC expects the candidates in the heat of the moment, in the pressure of the examination, to lose their concentration so that this can be ignored. You commit mistakes. That is where these trappings have to be caught. Okay, so this is incorrect. An IOD phenomena can influence an El Nino's impact on the monsoon? Always, yes. We have a positive IOD, negative IOD. They can always counteract the influence of El Nino on monsoon. So this is going to be correct. Correct answer. is going to be B. Now, the final topic for the day that we are going to study, that is the Madden-Julian oscillation, and then we will wrap it up for today. So here, already I'm seeing a lot of you with burdened point of thought. So in La Nina, does east coast of South America get rain? Eastern coast of South America. Okay. Yes, it will get some amount of rainfall because of La Nina conditions. Yes. So eastern coast, you are talking about the side of the Brazilian coastline. It will get. See, even if you want to know the details, Sushmit, basically, even in the case of Atlantic Ocean is not that wide, so you cannot expect a kind of a full blown Enzo cycle there. But there also you have around the region of the central equatorial Atlantic, you do have a different temperature which is maintained sometimes, which can initiate its own circulation there, own remote unique circulation there, what is also referred to as the Atlantic Nino. It is not a very full blown atmospheric circulation, but that tends to have a greater influence on the amount of rains caused in the region of the Brazilian coastline, and also on the other side, the African coastline. Okay. However, not relevant for your GS or your portion of UPSC. Now, Madden-Julian oscillation or MJO. So, as I told you, or if what we have studied till now, El Nino conditions are observed across the two ends of the Pacific because of accumulation of warm and cold waters. Indian Ocean dipole is observed across two ends of the Indian Ocean because of differential rate of heating and cooling. This induces a circulation in the Pacific and Indian Ocean, respectively. Now, it was in the 1970s when you had a couple of scientists who traveled to Singapore to actually study about the amount of rains, the impact, the disturbances observed in the equatorial climate. Because in equatorial climate, one expects occurrence of convectional rainfall on a daily basis. So they wanted to study that phenomena on the island regions. So that is when they visited the region of Singapore and they were carrying out their study. There they found something very interesting. While they were carrying out that study, they found out that every few days, that is every few weeks, you have the situation where the region receives very heavy amount of rainfall and then again it disappears. Again, that process is repeated after every 30 or 45 or 60 days. That entire process of heavy rainfall is repeated, again it disappears. So they were convinced that look, it is not a random occurrence, it is a circulation, an oscillation between heavy rainfall and less rainfall. So basically, they found out that there is also a traveling pressure system. While ENSO is a pressure system or a circulation in only in the Pacific, IOD is a circulation in the Indian Ocean, you have a traveling pressure system which travels across the planet from a direction of west to east. Because the planet also rotates in a direction of west to east. So basically, they observed that you have a traveling pressure system, low pressure, rainfall. This entire system, induced by the Earth's rotation from west to east, also does travel from west to east. So wherever this low pressure region lies, that area experiences rainfall. Wherever that high pressure region lies, that region remains dry. So this oscillation was named after those two scientists or the climatologists, and hence the name Madden-Julian oscillation, or in short, MJO. So Madden-Julian oscillation is basically an eastward moving disturbance of clouds, rainfall, winds, and pressure that traverses the planet in the tropics and returns to its initial starting point in 30 to 60 days on an average. Each cycle lasts for that duration. So you can think about this entire pressure system in itself traveling in a direction from west to east, moving in a direction from west to east, right? So you have a low pressure here, and the surrounding areas have a high pressure. Okay. Now, why does this system form in the first place? So there are various different views of this as per the first of all, not relevant for your GS, but as per the most accepted view, this entire low pressure system develops over the region of Western Africa. Now, there it develops, and aided by the rotation of the planet Earth from west to east, this low pressure system also travels eastward. And there is another factor behind it also. We will take a look into it shortly. So, basically, this is the circulation. Observe here. So, you have a low pressure system here. Now, what will it have? The winds will rise up, they will diverge, they will sink, there will be high pressure. So, the high pressure region will be sunny and dry, the low pressure region will be stormy and wet, right? So, the MJO is said to have two distinct phases, the low pressure and the high pressure. The low pressure phase is going to be the phase of enhanced or high amount of rainfall. This is the enhanced rainfall phase or the convective phase. The high pressure or the high pressure portion will have the suppressed rainfall. So, in a way, you can think about it. Let's suppose here you have the low pressure. Maybe from Western Australia, Western Africa itself, it originates. Understand, here we will also talk about how it traverses from one direction to the other. Low pressure, high pressure. Now, in the region of low pressure, very heavy amount of cloud formation, heavy cloud formation associated with very heavy amount of rainfall as well. Very heavy amount of rainfall here. Now, over a period of time, if I ask you about the temperature condition, the region of this high pressure, and listen to this carefully. Now, by the way, when we say the low pressure, we are talking about the convective phase or the enhanced rainfall phase. When we talk about suppressed rainfall phase, we are talking about the region of the high pressure region, isn't it? Now, if I ask you that in the region of this high pressure, you have sinking air means it is a kind of a dynamic high pressure. Now, here, there is no rainfall, sunny conditions, no cloud formation. So, what will happen to the temperature here? Slowly and steadily, temperature will start to rise because of lack of rainfall in the tropical area. You have clear sky means complete solar insolation also is falling. So temperature very slowly and steadily will begin to rise in this high pressure area. Are we okay with that? No? Excuse me. So I hope we are okay with that. Meanwhile, in the low pressure area, you will have continuous rains, very high amount of rains. So in this low pressure area, the temperature will cool down over a period of time. Slowly and steadily, the temperature will start to cool down, isn't it? So here, temperature reduces temperature reduces because of continuous rainfall. Here the temperature increases due to lack of rainfall. Fair enough? Is that understood now, Lakshmi? See, in the region of high pressure, you won't have rainfall. In the region of this high pressure, you have clear sky, high amount of sunlight, so it will get hotter and hotter. In the region of low pressure, you have continuous rainfall. So continuous in your area, wherever you are living. After 2 to 3 days of continuous rainfall, you experience that colder condition. Temperature reduces. So what are we seeing here? Are we not seeing the phase where this low high pressure gets converted to low pressure because of excessive heating? Now the low pressure will come here, so the winds will rise from here and they will fall somewhere else. So in this way, the entire system has moved from west to east. That is the case of the traveling MJO. So MJO, if you read it in detail, basically MJO is said to be divided into multiple different phases, stages. You basically have the first phase when it is present over the region of Africa. The second and the third phase as the MJO covers the Indian Ocean. Then the fourth, fifth, and the sixth stages as it covers the region of the Pacific and then moves over to South America. Then the seventh and eighth phases over South America and Atlantic. And then again, it regenerates from in the meanwhile from the region of Western Africa. When this MJO or the convective enhanced phase of MJO lies over the region of India or over the region of the central Indian Ocean, it is beneficial for Indian monsoon. This phase, when it lies over Indian region around Indian Ocean, during the monsoons, it causes more rains in India during the period. Okay, that is the case of MJO. Yes, the Sakshi, those total 8 stages of the development of MJO is not required for your GS at all. This is just the detail that I wanted to bring to your light notice so that you are aware that how this MJO basically transitions. Now, apply your logic and listen to this question very carefully. During the monsoon months, if that MGO cycle is very long, that is, this MGO takes 60 days to come back, India will receive more rains or less rains. During the monsoon months, if that MGO cycle is very long, it takes 60 days for the cycle to come back, India will receive more rains or less rains. Beautiful. India will receive lesser amount of rainfall because every time that the enhanced phase of the MJO is over the over the region of, as you can see, central Indian Ocean, India will receive more rains. But if it takes 60 days for that to come back, obviously the amount of rainfall will be impacted. That is why shorter MGO cycles during the monsoon months are beneficial for Indian monsoon. Okay, so let me write it down here. I hope you revise this, guys. Okay, that is why I keep on writing, but again, hope is a very bad thing. So, shorter MGO cycles are beneficial for Indian monsoon. And as the low pressure phase transitions over to Pacific, etc., India will receive lesser rainfall. Okay, so as long as this low pressure phase is over the Indian subcontinent and Indian Ocean, it is beneficial. Okay, so why shorter cycle? Prerna, that cycle, the shorter and the longer cycle, that is 30 days or 60 days, that basically is, are you asking why there is a shorter cycle? Is that the question? Or why shorter cycle will have more rains in India? What is the question? Okay. So the 30 days or the 60 days interval in the cycle period, that is determined by the formation of a competing low pressure. For example, let's suppose here you have, if you consider, here you have that low pressure. Let's suppose this region where you had the high pressure, this gets heated up very quickly. That means it will progress very quickly. Let's suppose the next region also then gets heated very quickly. That means it will transition. So when that heating is continued, the cycle becomes shorter. When that heating is not uniform, the cycles become longer. Okay, no, it is something which is existent almost weaker or stronger throughout the year. So that is where we'll restrict the session here today. On Monday, we will initiate the discussion from the portion of jet streams and we move ahead. Kindly revise this portion when you come on Monday. Okay, why it can't move backwards? It is aided by the rotation of the planet from west to east. That natural inertia is provided due to the rotation of the planet from west to east. So we meet again on Monday. Take care of yourself. Have a good weekend. Thank you. Goodbye. No PU. It doesn't mean that it originates only in June. No. As I said, stronger or weaker, it is in existence throughout. Longer cycles are not beneficial basically because it will take a much longer period of time. During that, monsoon season is not forever. Monsoon season is for 2 to 3 months. So within that time period, the other convective phase of MGO won't be able to return. As long as that enhanced MGO phase is there, it will accelerate the rains in India. Let's suppose that the enhanced rain portion has taken a longer time to come back. By that, the monsoon period might get over. That is why the quicker they come back, it is beneficial. Okay, Shahid, I hope that answers your question also. There is no class tomorrow here. Anjan, in La Nina, we see high pressure in Arabian Sea and positive IOD, we see low pressure. How can India receive? We'll talk about it in Indian geography, in the portion of Indian monsoon. In La Nina, you see the high pressure that is generally going to affect the Mascarene High, the locate Mascarene Islands before coming to the next class. Okay, right? Yes, Kushi. Sometimes it brings about or influences the rains during the winters in the peninsular part of the country. So, with that, let's meet again on Monday. Take care of yourself. Goodbye. Thank you.